Hey, folks. Small correction to the co-host. The talk won't be about GPUs, as you can see. Also, we've raised a little bit more than 700 million. Okay, that's an update. I want to apologize if something that I'm going to be talking about is a little bit obvious, or everyone knows about that. By the way, how many people know what AI is these days? Oh, come on, more hands? All right. How many people do use agents daily? Okay, I might have misjudged the audience. How many people create their own agents daily? That's great. What about getting those things into production? Less. All right. How many failures did your agent created in the past months? Okay, like 10 and more. 5. 1. None. Man. Frankly, it means you're not using it correctly, but good for you. That's the best. Okay, so quick intro. I have no idea why this picture is larger than me in real life, but our marketing team insisted. So my name is Dan. I'm CTO at the company called Nebius. Nebius is probably one of the largest specialized AI clouds in the world right now. We have started, depends on how you count, 4 to 2 years ago. There are different stages of maturity. I've been with the company from the very beginning. I'm responsible for the whole software stack. Our engineering presence is almost 100% in Europe, more than 60% in the Netherlands. Have a huge presence in Germany, some in Spain, a lot in London, and spread all over Europe. We serve clients globally. Our main asset is our GPU capacity and the cloud on top of that. And recently, about a year ago, we started paying more and more attention to the layer higher than that. We are talking about inference as a service. We are talking about agents. We are talking about the toolset around that. Because infra is great, but not everyone wants to use pure infra. So 2 years ago, and it's roughly when the whole thing started, right? So ChatGPT 4 was released circa the end of 2023. Almost 2 years ago to this date, Llama 3 models were released in open source, and that also pushed for a huge change in how people thought about AI, how portable AI becomes, how flexible the scenarios might be, etc., etc. But all we were worried about back then was how big. How big is the model? How many parameters? What's the architecture? What are the new capabilities? Is it smarter? Is it better at answering my questions? What is the knowledge cutoff date? You remember that was that actually was the term, right? So now, after 2 years of rapid development, revolution style, we are talking and asking about what can it do? What can it achieve? We stopped talking about architectures. No one really knows how many parameters are there in the latest OpenAI model. I don't. There are rumors, but no one is sure. And we've definitely started talking about applied AI, about AI solving problems, about AI doing stuff in production, in infrastructure, about AI sorting out client interactions, about AI sorting through the invoices. My personal assistant AI is competing with my human personal assistant on who controls the calendar now. And I'm not sure who is winning. So the shift from models to agents, it's shifted from the intelligence or model capabilities towards task execution. There is a goal you need to solve. there is like, it's less about chatting, it's more about doing, it's more about action. And this becomes an issue, because in order to run that in production, because in order to run that at all, that whole thing becomes an increasingly complex task, because the systems behind that become increasingly more and more complex. So just to recap, like, what did we measure during the model era when everything started? Parameters, flops, MMLU, benchmarks. We were doing human evaluations of the models, and human in the loop, etc. was like a big deal. Still is, but to a point. Bigger almost always meant better in terms of quality, not in terms of price. There is like a reason why amongst the Llama 3 models family that I mentioned, 70B, which is the mid one, was way more popular than the larger 400. But in general, there was a simple chart, and progress meant going up that chart, and it was more or less universal. The larger the model, the more capable it is. So what we shipped, it was like just pure inference. You have an endpoint, you send a prompt there, you get a response, that's it. Nothing more, nothing less. You've probably built customers if you are running inference as a service per million tokens or something like that, like per tokens, like the whole token-based economy, etc. And the mental model is always like, this is a chat, right? You ask questions, the smart oracle behind the endpoint answers. So now we are shifting, or already shifted, we've seen the hands, right, to a new way to think about that. It's not one shot anymore, it's multi-turn. It's not static capability, it's ever evolving. It's not text-based even anymore. Text is not important, and during the long-running agent sections, your interaction with the system becomes a tiny fraction of what's actually happening under the hood. Right, so the agent plans, it calls tools, it looks at the results, retries, it saves memory, it calls new tools, it devises its own tools, etc., etc., etc. So this is like one huge loop. What changed? Well, the main things that changed during these 3 years are the tool use matured. It was always like function calls. Like even in the very beginning, 2 years ago, the models were already able to call functions. They were trained for that. This was the way to interact with the world, execute code, for example, which was like, again, like a big thing back in the day. But in general, what we see right now with the complexity, with the likes of MCP, then skills, the whole discussion whether we need formalized tools or we just need free text descriptions of how to use CLI, whether when you create a new backend for the agent, do you need an MCP or do you need just like a proper documentation? Do you need an interactive CLI? Do you need a one-shot CLI? All of that evolved a lot, and the complexity around that evolved a lot. The other thing is, circling back, models became smarter, but not in the way of like just becoming larger, taking more memory, etc., etc., etc. Reasoning became a thing. Reasoning became way less expensive, cheaper. Reasoning, chain of thought, reasoning, so runtime, test time compute. Every model can now spend tokens increasing the amount of intelligence within a single shot, like a single call, essentially. So the more model thinks, which is essentially generating tokens, reading the tokens back to itself and generating new tokens, the smarter and the more capable it becomes. And of course, the expansion of the context. The earlier models were pretty limited. It can hold like kilobytes, tens of kilobytes of context, so whatever the model can think about. Now we're hitting millions. We're hitting a million in the closed models, DeepSeek was recently released, which also boasts like 1 million context, which is enough already for quite a complex tasks. So, and not only that, also like stuff like caching layer, so you don't need to recompute and run the whole 1 million tokens through your neural network. Made everything cheaper and more accessible, if you will. So, again, sorry for being obvious, but just a reminder. An agent is not a call anymore. It's a loop. It's constantly evolving. That's why it can run for hours. It can run for days even. But in an essence, it's still a bunch of model calls, reasoning behind that, and new model calls until you get the goal. So in principle, what's happening? You set the goal for the agent. It can be an interactive prompt and can be a closed loop for a very specific domain. Agent goes to the model, it plans, it acts, which is essentially tool calling all the time. You either call local tools like Bash, you call APIs, which is essentially the same. You can call specialized tools, which can have guardrails within them, but all in all, it boils down to running a tool which returns some new information. The agent sends it back to the model, so it's called an observation. So there is a tool, there is a result. We think a little bit about it. We decide what to do next. Either go back to plan the next action. We can retry if there was an error, but in a sense, it's just going in circles until the result is met. There's nothing else. It's pretty straightforward. What's not straightforward is the complexity of the software that is orchestrating that loop. Because everyone started with the simple while true do call the model, call the tools, done. Right now, we increasingly see that the amount of work and expertise that is put into harness, so the software that was orchestrating the loop, matters a lot. So at Nebius, we have this internal research organization that is working on essentially different problems around running open source models in production. And we had a stint exploring software development, right? Autonomous software development, AI solving real life problems. We have this SV Rebench leaderboard that is essentially once in a while the research team compiles the lists of the tasks from GitHub, from the open, which are guaranteed not seen by any model before because the tasks and the solutions for them were created after the model is released, and tests models' capabilities on top of that and have a ranking. By the way, anyone knows what's the top model for coding today? I do. Come on. Okay, obviously it's either OpenAI or Anthropic, right? So who's for Anthropic? Okay, third opinion. Who's for OpenAI? Roughly half and half. And your answer would be? Codex. Well, that's OpenAI GPT-5 based. Yes, actually, right now, GPT 5.5 is the best coding model in the world. Anthropic kind of lost its edge for a little bit. But at some point, with more and more effort going into harnesses, we started looking at how that performs against a very simple, like we have our internal test harness that's basically running an endless loop without any smartness or trying to optimize. And we started to adding third-party harnesses into the mix. And you can definitely see that the harness matters, that the percentage of the tasks that are being solved, backed by the same models, can differ. The harness can improve, but also if it's implemented in a questionable way with questionable optimizations, it can make things worse. And simple loop wins. By the way, like yesterday there were names here, but I was forced to change it for number 1 and number 2, but you can go and look for yourselves if you're interested. Another thing that gets to, like, partially adds to this problem and to this complexity is the fact that this is not a static thing anymore. And iterating on harnesses and available tools, which increases the quality of what the agent is doing, the feedback loop there became very short. For the model to go and release a new version, you had to go through extensive research, a huge data set collection, working through evals, training loops, consuming thousands and thousands of GPUs for a single run, etc., etc., etc. But what we see right now, and what we increasingly see right now, is that actually optimizing the harness, the tools around the harness, make it more domain-specific, hard code some of the solutions if you see that the model is steering away, for example, for a particular domain. Fine-tuning models on top of those traces and logs of your harness essentially becomes a thing. It increases quality, accuracy, and results of the agentic system so much you can't believe. So my strong belief is that this so-called agentic flywheel, when you run tasks, when you have all the logs, every plan, every action, every observation, every reasoning token, everything you can from the agentic loop, then you evaluate it, and it's pretty simple. The agent either did the task, achieved the goal, or not. It can be formalized in a very different ways, but still, you had a goal, you either achieved it, or you didn't. And then you improve. And improvement doesn't mean only post-training anymore. Improving means adopting your harness, which, by the way, can also be done by an agent. Improving means remodel the tools, change the way tools behave, change the amount of tokens the tools consume when they work, etc., etc. And it substantially increases the success rate of completing the task. So this is not just the big AI researchers, AI labs tasks anymore. This is pure software engineering, nothing else. So, given all that, what does it mean if you are practically doing things, whether you build, you buy, or run AI, modern AI in general? So, the shift that we see, inference is the workload now. 2 years ago, when we were starting and spinning up large clusters and talking to large clients, 98% of our workloads were training runs. Pre-training, post-training, fine-tuning, doesn't matter. Our clients were researchers, and the way they consumed the GPUs was atrocious, but the main consumption point was training. It's shifting. Training is the subject of, is the function of the amount of researchers and labs you have. Inference, and the amount of inference workloads is the function of, AI penetration, right? So the more the audience is, the more use cases require, the more inference workloads we see. So inference efficiency, the speed, the optimizations there become a huge hot topic. Orchestration is the product. As I've said before, working on the way harness works, on how you orchestrate the models, how you plan, how you solve the long-term memory problem, how you solve the tools and the subset around that becomes a big thing. Not that the model is not necessary anymore, you still need the capable model, but this becomes a factor and a huge one. Evals shift from one-shot prompts, whether the model can answer right, to the whole trajectories, 10 steps, 50 steps, 80 steps, 200 steps, and the workloads are long-running. More than that, they are not only long-running nowadays, they also can pause and wait for a long-running batch workload to finish, come back to the harness, wake up the model again, and continue from that on. That's how we see, for example, when models are doing modern research tasks, when the run of a tool spans for hours, for example, Model's not doing anything. They're just waiting to be woken up and continue with the cycle. These are important shifts that we see, and this puts a lot of impact on how we think about infrastructure nowadays. Buying agents nowadays from any kind, and by the way, if you are building agents, your clients will ask you that. It's not about demos anymore. It's not about the stated capabilities anymore. It's not about what models do you use anymore. No one cares about models that work behind the agents. More than that, agents increasingly shifting to the full orchestra of models for different tasks, subtasks, or different actions. We see that people who are consuming agents and agentic workloads stopped caring about demos and how fancy it looks in the deck or during the call. Everyone is focused on, and because it's about tasks and business goal, everyone is focused about, can it solve my particular problem? Can it evolve to solve my particular problem? Can it work within my environment? Can it access my data? How effective is it at accessing my data? How does it work in general? And because the agent workloads became increasingly autonomous, everyone is concerned about audit logs, cost caps. Everyone heard those messages about OpenClaw costing some independent developer like tens of thousands of dollars, or destroying the whole production within minutes and then saying, "Oh, I'm sorry, you are right, I should have done it differently." So audit logs, cost caps, approvals, the ability to roll back, to control the blast radius if something goes off, is becoming an increasingly important task. You simply cannot have a production use case without it anymore. So, just to recap, what are the buyers asking when they're talking about procuring an agentic product or embedding an agentic capability into their products or life? Can I inspect every step? Is the audit there? Do you have the observability tools, etc.? Can I replay failures? If something goes wrong, can I correct and do it again? Can I cap the cost per task? And actually, budgeting and autonomous model routers become a thing right now because of that, precisely. Because for hard tasks, you probably need the most capable model. For smaller tasks, if you can predict that it's a small one, you can go back to the smaller models all the way to some open source 8 billion tiny model just for the fact. Actually, for example, in our research, we see that running the loop, as in planning, it almost doesn't matter whether the model is most capable or least capable. What matters is observation and going back and interpreting the results. But then orchestrating the whole loop, the smaller models are very capable of that as well. Can I set autonomy levels? This is more about the harness, the tooling. What can the agent do? What can't it do? Can I interfere? Can I stop them? Can I put the guardrails in? Can I approve risky actions, which is essentially the same? If the autonomy level is high, is there a way for the system to raise the question, this seems dangerous, will a human approve? Can I measure completion on my workflows? So again, whether it's successful or not, how do you formalize the success criteria, or is it just running around in the wild? And as I've said, no more show me the demos anymore. POCs, small blast radius, real life environments, real life data, because it's highly contextual, because there is no one size fits all solution anymore. Everything becomes super custom. Everything evolves into a particular workflow, into a particular domain. So agent infrastructure is essentially about runtime again. Less about inference, more about going back to the beginning of Web 2.0 era. Is the same scaling problems, is the same runtime problems as we've had before. The workloads become burstable because it is very uneven, because every agent loop is driven by a number of factors, the reasoning, the tool calls, the length of the tool calls, etc. So it becomes an issue of planning. It becomes the issue of infrastructure around to become stateful. The more stateful agent becomes, the better it performs. And it's about control execution, whether your system is reliable, whether it can roll back, whether it can retry, where it can reconcile after the mistake or a problem, etc., etc., etc. So we see increasing demand for the harness, for the tools, and for the infrastructure around it that can orchestrate that at scale. This is a weird slide with a bunch of texts, but essentially it says if you don't do all of that, you're doomed to stay in the POC phase. And that's why I've asked at the beginning, like everyone runs agents all the time nowadays. Most of those use cases are in the testing phase, and sometimes are in the testing phase forever, because the outcome matters. So if your long-running tasks are not successful enough, it stays there. If you don't know what is happening, it stays there. If you don't know how much it will cost, no one will sign off on scaling up the production workload. Security, blast radius, permissions, human-in-the-loop intermission, etc., etc., etc. This all matters. This becomes a factor. So what I strongly believe is that the whole agentic workloads are like, this is the thing that is definitely getting traction nowadays. And the next year, in majority, will be spent around hardening it, about making it more predictable, about making it manageable, observable, whatever the word you can take there. I doubt we will see huge improvements or breakthroughs, but the steady, ready-to-production phase is beginning right now. We see a lot of enterprise adoption, or at least talks about enterprise adoption. But for those projects to succeed, you need it to be reliable, which most of the workloads are not right now. So, yeah, just to recap, 3 predictions I'd be like, I'm ready to talk in a year and see if that's true, but I'm pretty sure about that. Compute shifts from training to inference a lot. We stop talking about tokens at all. No one will care, and we will start talking about outcomes. And by the way, you can definitely see that trend already when huge SaaS companies are introducing their AI capabilities, and they're not talking about subscriptions anymore. They're not talking about tokens anymore. They're talking about solved tickets. They're talking about successfully completed workloads, and they bill for that. I think the first pioneer was Anthropic with their $25 per pull request review on GitHub. But the likes of Salesforce and ServiceNow are doing exactly that right now. They're building their agentic capabilities, and they're starting to build their clients on the outcomes, actually completed tasks. And no one cares how much cost and how many tokens were spent. And eval on the agentic loops becomes the infrastructure, becomes the key infrastructure level. Because in a sense, this is the byproduct, the side effect of generating an outcome. And it holds a ton of valuable information on how to improve that. Again, sorry if it was obvious for a lot of you, but I felt the need to set the baseline for today. I've seen a lot of exciting topics about the talks on agentic, infra-agentic use cases, etc., etc. So I felt the need to recap. If you want to discuss something, find me. I'll be here all day. See ya.